Hi everyone, this is Vincent Willegachen again from Complex Chemistry Simplified, and today we are looking at the second example, but this time a weak base and a strong acid. So we have 50 milliliters of this base and then 75 milliliters of nitric acid. This one is 0.44 molarity and this one is a molarity of 0.32. So, and the Ka value for nitric acid is unknown, and they want us to calculate that value when the pH value is found at 1.83. So what we first have to do is write a balanced equation for this. Okay. Well, then we have to calculate the initial number of moles of both the base and the acid. And the answer will be 0.022 mole. And for the acid it will be, let's calculate it quickly, 0.32 times 0.05. Remember that the milliliters will be derived to liters. I do not know this answer yet. I did know that one. It's just, I don't want to make any unnecessary errors. That one is 0.024. Okay, now we can see that the acid is again in excess. And that excess amount will be 0.024 minus 0.022 is 0.002 mole. Now we write yet another balanced equation for the excess amount of nitric acid. So now we will have it's the conjugate base. So this initial amount needs to be derived to molarity. Remember again to add both the volumes together in order to have the molarity. This one will not react, it's not in a solution, it is liquid, so it's not in the same phase as all the others, so it will not be taken into account for the equilibrium. This one was 0 and will be X. This one was 0.022, but remember to divide it by the total volume. Plus X. Well, the pH value was given as 1.83, and we will need that to calculate X. Then we can calculate the Ka value. It's minus log of hydronium ion concentration, or it can be just the H plus ion concentration. But here we have hydronium, so we can use that as well. 1.83 is minus log. And then you can quickly say that hydronium concentration is, and that will give a value of, substitute 1.83 here, it will give you an amount of 0.01479 I think we can use, I think 6 decimals is enough. So now we have this. This will be, I think it would be easier to derive this to a number. It looks very strange as it is sitting there. And then this one will be ruled out. I think we can leave it at x as it is now. And then we have to calculate this as well. It will be 0.176. Now use another color for this. Okay, a Ka value is unknown, but we can substitute these. And then it was this. I think you can substitute the values in the meanwhile. Divided by so we can substitute this into the calculator. Plus answer, then you have to don't have to insert it again. Divided by 0.016 minus, now I will have to insert it again, unfortunately. 791. It will give us a value of 2.33 and then some decimals, but I think it's safe to take this. Well, if you will look in the table of Ka values, you will find that Ka of nitric acid is 2.4, so it's very close to this value here. So although it's not exactly the same, remember that there might be some impurities in it, or even the base might have contained some impurities, or so it's okay if it's not exactly the same. And also maybe the 1.83 was also not exact, so it might have been 1.8294 or whatever. So it could have slightly changed the value, but I think it's safe to say that this value is quite accurate. So I hope you understood this one, and I see you for example 3 tomorrow.